In this chapter, we will explore the fascinating world of processes and threads. Operating systems rely on processes and threads to manage and execute programs efficiently. These concepts are fundamental to understanding how modern operating systems work and how they enable concurrent execution and resource sharing. Let's delve into the details of processes and threads, their characteristics, management, and synchronization. By the end of this chapter, you will have a solid understanding of how processes and threads operate and how they contribute to the overall functioning of an operating system. So let's begin our journey into the realm of processes and threads. Introduction to processes. In this slide, we will discuss the introduction to processes. A process is an instance of a program in execution. It consists of a program counter, memory, registers, and other resources. Processes are independent entities that can be scheduled and managed by the operating system. The process control block, PCB, is a data structure that stores information about a process. It includes details such as process ID, state, program counter, memory allocation, and I/O status. The operating system uses the PCB to manage and control processes efficiently. Multithreading and thread management. Now let's explore multithreading and thread management. A thread is a lightweight unit of execution within a process. Multiple threads can exist within a single process and share its resources. Threads allow for concurrent execution and improve performance in certain scenarios. They can enhance responsiveness and interactivity in applications. However, multithreading also presents some challenges. Synchronization and coordination between threads become crucial to prevent data sharing conflicts and race conditions. Debugging multithreaded applications can be complex. Thread states and thread synchronization. In this slide, we will focus on thread states and thread synchronization. Thread states represent the different stages a thread can be in during its execution. These states include: new, the thread is created but not yet started; runnable, the thread is ready to run and waiting for the processor; running, the thread is currently executing; blocked, the thread is waiting for a resource or event to proceed; terminated, the thread has finished its execution. Thread synchronization ensures orderly access to shared resources among multiple threads. It helps prevent race conditions and maintain data integrity. Techniques like locks, semaphores, and monitors are used for thread synchronization. We hope you found this lesson on processes and threads informative. If you enjoy the content, please like this video and share it with others who may benefit from it. Don't forget to subscribe to our channel and press the bell icon to receive notifications about future lessons and updates. Thank you for joining us, and we'll see you in the next lesson.